And I'm going to start talking about the homework which I assigned you previously. I already did quadrant 1 for you, and I told you to do quadrants 2nd, 3rd, and 4th. And hopefully you noticed that the values which you needed to fill out the information for 2nd, 3rd, and 4th quadrant was only the value which we actually got in the first quadrant. For example, or for instance, for 120 degree, you can see the height is same, which means the y coordinate for 120 and 60 degree will be same, and x coordinate, the difference between x coordinate of 120 and 60 will be only that for 120 x is negative and 60 for 60 x is positive. So I'm going to show you the values, and hopefully you got the same values. I haven't checked your homework at this point because the date of submission is tomorrow. So let me show you. So here, if you look at, so if 60 degree 1 over 2 square root of 3 over 2, and you have exactly the same, only difference is x value is negative. So you could have used these values to fill out all the values. And I hope you did notice for 135, it's same as similar to 45, and 150 is similar to 30, no change there. And now here, first and fourth quadrant, you can do after you do first and second, you can switch to you can do first and fourth, or you can do second and third. For first and fourth, if you look at for 30 degree and 330 degree, the x value here is same, and the only difference is of y. Y is positive here for 30, and here y is negative. So it was pretty straightforward, and I hope that you got all the values correct. So this was the first thing which you were supposed to do, and then I asked you to fill out the information in a table, and using x is equal to cos theta since it's a unit circle, and y is equal to sine theta. So for all coordinates, you are supposed to fill out what is sine 0, for example, and then you will see sine 0 is 0, and cos 0 is 1, and sine 30 is half, cos 30 is square root of 3 over 2, and hopefully you got that also done correctly. So I'm not going to fill out that information for you, but this was based on what you already have. And for tan, you did sine theta over cos theta. So for 0, this will be tan, 0 will be 0. And then for tan 90, you must have noticed you got 1 over 0, which is infinity. Infinity means it's not defined. And then similarly, you could have noticed you will have a lot of infinite values for tan here. If I keep on extending this, then you will notice that there will be few angles where tan will be infinity, which means not defined, when you get 0 in the denominator wherever the cos values was 0. So that was your part 2. And then in part C, I asked you which trig ratios are positive and negative. So I hope that you notice that here first quadrant means between 0 to 90 degrees. So first quadrant here means 0. Sorry, okay, so first quadrant is, okay, some issue here. So here, so in first quadrant you have 0 to 90, so 0 to 90 degree here, and if you look at 0 to 90 degree here, so 0 to 90, I don't know what's wrong here, so 0 to 90 degree here, so here your sine theta, cos theta, and tan theta, all of them were positive. So what you need to do is you need to go back, and you can see from these table values from 0 to 90, sine, cos, and tan, all of them were positive, and from 120 to your value till 180 degree, you can go back and see that here sine was positive, but cos and tan was negative. And here in third quadrant, you must have noticed that tan was positive and sine and cos was negative. Okay, I will try to write one more time here. So here, I'm going to write down here this A. A means all positive. So sine, cos, tan, all were positive. Here, it was S, which means sine was positive. Here, you have T, which means tan was positive, and here cos was positive. So this is C. So you always should remember it by A, S, and then you had T, and then you had C. So A stand for all, A means all, S stand for sine and sine theta, and T stand for tan theta, and C stand for cos theta. So they are positive here, cos theta. So the way I remember is that all add sugar to coffee. or you can say all students take calculus. So this is the way to remember which trig ratios are positive in which quadrant. So that was your part uh, C, and it's also straightforward here because it's mentioned here positive positive, and we know that x is cos theta, y is sine theta, and if cos and sine is positive, so is tan, because tan is sine over cos. And here we know that your x is negative, which means cos was negative, but sine was positive because sine is y-axis, and then tan will be negative. Here, because sine and cos both are negative, which means tan has to be positive. And here, your cos was positive, but sine was negative, therefore tan was negative. So if you didn't find this information, make sure that you take notes as I am going through this. So make sure you do that. This is quite important. All add sugar to coffee, or all students take calculus, because we'll be using this information with all other information to solve trigonometric equations. So please make sure that you are recording this information in your notebook. Now, after this, I asked you to find out what is sine 90 minus theta, cos 90 minus theta, tan 90 minus theta, and so on for all the quadrants. For the first quadrant, if you go back and if you see here, so what was the value of, let's say, for instance, sine 30? And I hope you noticed whatever was sine 30 was cos 60. And whatever was cos 30 was sine 60. And sine 45 was same as cos 45. I gave you that hint as well. So which means sine 90 minus theta is equal to cos theta. And cos 90 minus theta is equal to sine theta. And you know in first quadrant, this is positive. So this was this was cos theta. So cos theta. Okay, I don't know what's wrong. I'm not able to write down here. And this one was sine theta. So this is sine theta. And tan theta, I will not do this at this point, and I'm sorry that I included tan 90 minus theta, since I told you we are just going to focus on three trig ratios. And for tan 90 minus theta, since it is equal to cot theta, and I was not expecting you to find out that, so don't worry about this tan 90 minus theta. The next one was sine 180 minus theta. And if you remember, sine 180 minus theta again, I will go back to your table and you can look at what is the value of sine 135 in your table. And then look at the value of sine 45. And both of them is same, which means that sine 180 minus theta is equal to, so sine 180 minus theta will be equal to sine theta. So, and it's positive because in second quadrant, if you know that sine was positive, cos 180 minus theta is in second quadrant and it is negative. So this will be minus cos theta. So it is minus cos theta. I'm not writing all of it. And here this will be minus tan theta. So tan 180 minus theta is also in second quadrant. And if you remember, sine was the only thing which was positive in second quadrant. So this is 180 minus theta. The another observation, why did I ask you only 180 minus theta? Because I can ask you sine 90 plus theta, because 90 plus theta is also in the second quadrant. I didn't ask you because if you go back and see, whenever you are working with odd multiples of 90. Now, what is odd multiple of 90 means? So if you are working with odd, so odd multiples of 90, which means I'm talking about 90. So this 90 is 90 times 1. And then 270. So 270 is also odd multiple, 90 times 3. So if you are working with odd multiples of 90, sine get changed into cos, and cos get changed into sine. Whereas if you are working with even multiples, then you remember that sine 180 minus theta was sine. So sine remains sine. Cos remains cos, tan remains tan. So we will be using, for the first quadrant, yes, we need to do sine 90 minus theta and cos 90 minus theta. So we need to know that, these two values only. But then for others, we will be using sine, cos, and tan in terms of 180 minus theta. Similarly, I ask you to find out for third quadrant, and again, the third quadrant, you know, tan was positive, and we know when it's 180, the tan remains same. Again, if you want to go back and check it, you can see that tan 225 will be same as tan 45. So that means this is also going to be, so this was equal to tan So this is tan. So this one was tan, and this one was minus cos. So this is minus cos, and this one was minus sine. So this is minus sine. And then for fourth quadrant, it's similar to the third one. So here again, it's 360 minus theta. And in fourth quadrant, you know that cos was positive. So this was positive. So this is cos theta. And this becomes minus sine. And this one was minus tan. And similarly, minus tan, and similarly this one will become minus sine theta. So this theta, the negative of theta will come out, so minus sine theta. This will be cos theta, so cos theta, and this one is going to be minus tan theta. So I hope that you understood, and if you know any, if you need to go back and review this, please make sure that you review this, because as I said, we'll be using this for solving trig equations. So, and now I'm going to move to the next step, which I have to do. So I hope that the one thing is that I'm not asking you to memorize all of these values. And when we'll be solving trig equations, we can use this unit circle to find out, or the graph, which I'm going to like do in few minutes. And you also need to know how to solve it algebraically, which again we'll be doing in coming lessons. So what I'm going to show you here is that if I want to find out, let's say sine 240 degree, what is the value of sine 240 degree? I don't think that we did 240 above in the unit circle. So if you look at, go back, we didn't do 200. Oh, we did 240 degrees. So we can use the unit circle. So sine is this. So answer will be negative square root of 3 over 2. So you can use unit circle to answer that. Now, the next one, if we want cos 315, again, you can go back and use the unit circle. So there are the trig ratios in terms of secant and cosecant and cot is also given. So I'm not going to do those problems. And if you want to challenge yourself, yeah, go ahead and do that as well. So whenever you are trying to find, if the another option is, if you do not want to draw, let's say the unit circle, right now you have a unit circle, so you can do that using unit circle. But if you don't, then how can I do it without actually using the unit circle? So that's what is coming up. Uh, to be able to do the questions without using unit circles, so what you need to do here is that you need to memorize the table. You need to memorize the table for sine, cos, and tan for 0, 30, 45, 60, and 90. These are the common angles, and you need to know them. Okay, with that, I will also advise you to kind of extend it for 180, 270, and 360. So that is also will be good too if you know them by heart. So now here, how do we construct this table? I mean, I remember the value. Sine 0 is 0. This is half. This is square root of 2 over 2. This is square root of 3 over 2. And sine 90 is 1. And for cosine, it's in the reverse order. So if this sine 90 was, because I know sine 90 minus theta is cos theta. So then this will be 1. This is a square root of 3 over 2. This is 1 over square root of 2, or square root of 2 over 2. 60 will be half, and then this will be 1. So sorry, this will be 0. So this is what is the value. And now easier way to remember it, have a look and then make sure that you remember that. So the easier way to remember this is you start plugging value 0, 1, 2, 3, 4, and then you reverse it 4, 3, 2, 1, 0. It's not completed yet. And then you divide everything by you take the square root of all, and then you do divide by 2, 2, 2, and 2. So once you do that, what is square root of 0 is 0. So 0 over 2 is 0. Square root of 1 is 1. So this gives you 1 over 2. Square root of 2 cannot be simplified. So it will stay same. Square root of 3 cannot be simplified. So that will stay same. Square root of 4 is 2. So 2 divided by 2 is 1. And that way we will have the table ready for 0, 30, 45, 60, and 90. Now, these are the values which you got on the unit circle also. I would like you to make this table in your notebook, but add an extra row for tan theta. So tan theta is sine over cos, so this will be 0. This is going to be 1 over square root of 3. This is 1. And then you have square root of 3 and infinity. And I would also like you to extend this table and have the values for 180, 270, and 360. Okay, so pause the video here and then make this table in your notebook with addition values for 180, 270, and 360, and also add another column for tan theta, another row for tan theta. Now, I should be able to use, if I remember or memorize, or if I know how to actually make this table, as you know, we explained previously, then I should be able to do sine 240 without actually using the unit circle. So I'm going to show you how to do that. To be able to do this, we are going to use the relationship which we did in part D of our previous task, come investigation. So sine 240 degree, whenever you are trying to find the values, you always have to use these angles, 0, 30, 45, 60, or 90, and always try to change this in form of 180. So whether it's 180 minus theta, always even multiple of 90. So 180 minus theta, or 180 plus theta, or 360 minus theta. So I'm going to change sine 240, as you can see from here, sine 240 can be written as 180 plus 60. So 180 plus 60. Sorry, I don't know what's wrong with this. So 180 uh, plus 60. So that is your sine 240. Now you know that, which means sine 180 means it will remain sine. First of all, I'm going to decide on whether it's sine or cos, and I don't have to decide anything because, you know, if it's an even multiple, it doesn't change. So this is sine 60. Now 180 plus 60 is in the third quadrant. And if you remember, add sugar, so I always remember like that. So add sugar to coffee, which means third quadrant, tan is the only positive one. Sine is negative, which means here you will have minus sine 60. And sine 60 is square root of 3 over 2, which means the value of this is going to be negative square root of 3 over 2. So, and then you can go back and see in your unit circle. I remember that sine 240 was negative square root of 3 over 2. Now, I would like you to give it a try. So pause here again, try number 2 and try number 4. No, sorry, don't do number 4. So do number 2 and number 5. And without using unit circle, using this table and using add sugar to coffee. Okay. Then after that, I'm going to move to the graph of, and just to recall that we did this trig identity, sine square theta plus cos square theta is equal to 1. There are few more trig identities. Again, since we are just dealing with sine, cos, and tan, so I'm not going to kind of like emphasize more on it, but I'm introducing that so that those who are challenging themselves can use those trig identities. So it's 1 plus tan square theta is secant square theta, and then cot square theta plus 1 is cosecant square theta. But we'll be mainly using the questions, even the trig equations I will be doing with sine, cos, and tan. So now I'm going to move to the graphs of sine, cos, and tan. So we already know the unit circle, so we already know the values. So here is the values for sine, 0, 30, 45, 60, 90, 120, 135, 150. So these are the values. When you plot them on x-axis, so on x-axis you have 0, and then here the value is 180. 180 is, sine 180 is again 0, as you can see from here. I don't think we need that many values. You can even use sine 0, then you can use sine 90, and then you can use sine 180, and then you can use sine 360 and sine 270. So if you use only these values, so like 0, and then 90, and then 180, 270, and 360, then you will see the shape of this graph. The another observation I would like you to take from here is that if you look at the maximum value of sine is 1, and the minimum value is -1. So you can see here the maximum value. This is the maximum value, and a -1 is the minimum value. Okay, now if you will extend this graph, and we can use technology to do it, so you can actually use your GDC to do that. If I extend it, let's say between, right now it's 0 to 360, if I do 0 to 720, so you will see that the whole thing will repeat, which means the period of sine is 360 degrees. So in 360 degree, it completes a complete revolution. So, and 1 is maximum value, -1 is minimum value. And this is also called, the height of this graph is called amplitude. And you can see that the amplitude is 1 here. So the amplitude here is, amplitude here is 1. And then you can also see here, this is called principal axis. So I will do another video on the graphs, what is amplitude, what is the principal axis, all of these things I will do in another video. But you can see here the domain of this is all real. So here, so you can see this is the amplitude, but I'm going to talk about this in coming lessons maybe. And then this is called the principal axis. I'm not going to, so I'll come back to that. So this is the graph of sine theta. The period is 360 and it will repeat, but I will do that again. And then, okay, so here you can see that. So from 0 to 360, you can see 1, then again, second cycle, and then you have in this direction also. Okay, so similarly for cos x, again, you can choose the value 0, 90, 180, 270, and 360. And if you plot it, the graph of cos x looks like this. Again, I will highly recommend you to actually sketch them in your notebook. And then again, maximum value cos can take is 1, and the minimum value cos can take is -1. And the period of this is also 360 degree, and by period I mean that it will start repeating, so you will get the same shape again. So that is the period of cos x. So, and this is how it looks like. It looks like very similar to sine now, and there is a relationship, as sine 90 minus theta is cos theta. And what does that mean in terms of like 90 minus theta gives us cos theta means what? So it's kind of a translation, but I'm not going to talk much more in this video about that. Okay, so this is your sine cos, and now I'm going to show you the tan one. Sorry. Okay, so if we look at the tan, so the graph of tan theta looks like this. So the graph of tan theta looks like this, and here these lines are, no, sorry, these lines, the red one, these are the asymptotes where tan is undefined. So as you know, the first value where tan is undefined was 90, tan 90 was infinity. So when you start the graph of tan x, you need to first draw the vertical lines as an asymptote, which will be corresponding to 90, then it's 180, then it's 200, so it's 90, sorry, then it's going to be 270, I'm sorry, and then it will be 450. So after every 180 degree, you will see that the tan is undefined. Again, you can go back in your table and see that. And then tan 0 is 0, then tan 180 is 0, tan 360 is 0, and then the shape of the graph you get is this. You can have a little more values, and then you can see this, and this is how you can also see that how it is going. And yeah, so you change the value of tan and then you get this curve. So this is the graph of tan, and the period of tan is 180 degree. There is no maximum or minimum value to tan, as you can see that, because this keep on increasing and this keep on going down in this direction. So that is it about today's lesson. So sine, cos, and tan. And yeah, I found this interesting actually. I just wanted to show you that as you move in the unit circle. So if we start from here and then we go, or maybe 0, because if it's 0, so you can see, then you go up like this, and yeah, I found this interesting, and then you can see how the sine graph is coming. And the another example of sine will be here. So if you have If I play here, and then a sine wave produced naturally by a bouncing spring, I found is fascinating. And you might be doing like in a pendulum in physics also, you will come across this kind of shapes. Sound waves, is an example of this also. So I found that very interesting. So that's it. And I'm not setting any homework assignment for today's lesson based on what I did in today's lesson, but I am setting up a quiz which will be your homework, and the quiz is on the non-right angle trig, like when do you use sine rule, when do you use cosine rule. Okay, thank you.